these physics puzzles. So the way that I think makes the most sense to solve a puzzle like this is to realize that in order to find the acceleration going of this basket going horizontal, you need to find first what this friction force is. But we can't find what that friction force is without knowing, if you look at what the friction equation is, without knowing, it should be K, without knowing what this normal force is right there. So first we need to find that normal force. When we find that normal force, then we can find the frictional force. When we find the frictional force, then we can add those horizontal forces together and we can see what the overall force is going to the right. Then when we find the overall force going to the right, since we know what the mass is of this basket, we can solve for the acceleration. So I kind of went backwards there. The question asks what the acceleration is. So that's what we don't know. We don't know what the acceleration is. To solve the acceleration, well, we have the mass, we need the force, but the force going in this x direction here, or in the horizontal direction, we don't know what that is because we don't know what this frictional force is. To solve for the frictional force, we've got the coefficient of friction, but we need to find what the normal force is. And we can find what the normal force is by adding all those forces up in the y direction. Okay, and the reason we do that is we know that the y direction is the overall forces in the y direction is 0 because this basket isn't going up and down. The basket is just staying flat on this surface. So we were given kind of like the lead in this puzzle here. We know that this basket is not going up and down, so we know that all the forces in the y direction, so the sum of all the forces in the y direction is 0. So we also know that if we add all the forces up in the y direction here, so that includes, I'm just going to write out all the forces. So the force due to tension in the y direction, so that's this force right here, plus, let's look at all the other forces in the y direction, plus the force due to gravity. So let's look at the force due to gravity. Put that on there. Force due to gravity, plus the force due to the normal force, I guess, the normal force. All these forces added together will give you 0. So we're not including this diagonal right here because we've already decomposed it into the y and the x components. So we're not going to consider this purple right here. It's not an extra force here. We've just decomposed it into the x and the y components. Okay, so if we add all those forces up, we'll get 0. We know that because this basket is not accelerating up or down in the y direction. So let's do it. Let's figure out what this is. We know what this is right here. We can calculate that in a minute. This force due to gravity is always going to be mass times the acceleration due to gravity. So this right here is going to be mg. Okay, and we know what those numbers are. We don't need to write them out yet. We don't know what the normal force is. So that's our kind of like unknown right here. So what I'm going to do is I'm just going to rewrite this so I can solve for the normal force. So all I'm going to do is subtract this, and this from the normal force. So I'm going to have the normal force equals, let me just rewrite this here so it seems like it makes sense. Normal force equals negative Fg minus Fty. Okay? That's all we have to do. So if you put all those numbers in, so this is the number for Fty, right there. And if you put mass times acceleration due to gravity, which is negative 9.81 meters per second squared, you're going to get, as our overall normal force, I'm not going to go through the details of this, I'm just going to tell you what this normal force is. The normal force is going to be approximately 121.625. 121.625 newtons. It's always in newtons. Okay, so that's a normal force. Great, we got the normal force. Now we've kind of unlocked this problem. So now we've got the normal force. We know what this coefficient due to friction is right here. So we can figure out what the frictional force will be. So all I'm going to do right now is I'm going to plug this normal force into this equation right here, and I'm going to get the frictional force. So here's a frictional force. The frictional force is going to be, I've just plugged it in. You put this number into that equation, you put this number into that equation, and you're going to get for the frictional force, let's see here, the frictional force is going to be, let's try to use similar colors. Frictional force is going to be, where is that color? Frictional force is going to be 69.083. 69.083. I'm using extra sig figs here. So that's our frictional force. Okay, so that's this number right here. But since it's going in the left direction and we want to go into the right direction, I'm going to make that a negative number, just so I know the direction of it. Okay? There's nothing in this problem that tells you that it should have been negative except for looking at this right here and saying, okay, that's going left, and we're calculating right. So it's going to be working against your force, so you're going to the right. Okay, now, since we know what this force is here, and we know what this force is here, we can figure out in the x direction what the what the force should be. So let's look at the x direction here. So if we look at the x direction, so this is the force in the y direction, but if we look at the sum of the forces in the x direction, maybe that's a little bit too light. Some of the forces in the x direction, it will be mass times acceleration, and we're trying to find, we know what the mass is, we're trying to find the acceleration. It's going to be to the right here. So the sum of the forces in the x direction, they're going to be ftx, that's a tension in the x direction right here, we know that number, plus, I'll put it behind it here, plus the frictional force. So it'll be the frictional force plus that. And since the frictional force is this negative number right here that we plug in to this value right here, we can figure out what this mass times acceleration should be. So if this will equal ma. So this whole thing right here, if you divide that by mass, so it'll be f of f plus f of tx divided by m, that'll get you your acceleration. And that's what the final answer is going to be. So your overall final answer should be 0.527 meters per second squared. Now the reason I went through this entire problem is because there's lots of steps, there's lots of places where you could go wrong, and you've got to keep everything very organized. So in solving the puzzle, you have to stay organized. Make sure that you stay organized. These are general principles for solving a puzzle in physics. Okay, so in general, know that these are the equations that you use. You can use some trigonometry to figure out these vectors in here, but you should know that all forces are vectors, which means they have a magnitude and a direction. So this angle right here shows you the direction. You need to draw this scenario, think about trigonometry, write down the info that's given, write down all the info that's given, usually on this little diagram right here, and then solve the puzzle. And there are ways that you can solve the puzzle, but always stay organized. Yeah, so that's really all I can tell you for those kinds of general ways of solving these problems. The best way to do this and the best way to know how to solve the puzzles of these problems is to go through and actually work through the problems again. My advice would be to look at your workbook, cover up your answers, and see if you can solve the answer on a fresh piece of paper, and then compare your answers that you just put down to the answers that you know are correct. And you should have all the answers. I know that I've attached all the answer keys to your problem set, so I know that you've got my answer key. So if you have any questions about that, please let me know, but I think that should get you going and get you studying for this test. I suggest going over in detail, going over the friction, static and kinetic friction problems. Definitely think about those. Look at, I didn't even talk about every force has an equal and opposite force. Look at the elevator problems. I've got lots of review on that online. Yeah, that should get you going. Okay. So good luck, and let me know if you have any questions.